307 weather alerts are active across the United States right now, and there is not a single organized storm system anywhere on the map to explain them. A dip in the jet stream has lodged itself over the Rocky Mountains and stopped moving, and from the Rockies to the East Coast, severe weather is possible every single day for the next week and a half. By the end of this video, you will understand exactly what is coming, day by day, and why forecasters can see this danger clearly and still cannot tell you where it lands. The United States has entered a severe weather pattern with no clear end in sight, and forecasters expect it to run for the next 7 to 10 days. As of the latest update, the National Weather Service had 307 active alerts in effect across the country. From the Rocky Mountains to the East Coast, damaging winds, large hail, and isolated tornadoes are possible somewhere on the map every single day for well over a week. Here is what makes this pattern different, and what makes it harder to deal with than a normal severe weather event. There is no storm. There is no hurricane with a name, no sharp cold front marching across the map, no organized low-pressure system you can watch on the radar and track from one state to the next. There is nothing for a forecaster to circle and say, this arrives Tuesday and clears out Thursday. What the country is facing is not an event. It is a condition, and the condition is going to sit in place. That distinction matters because it changes what forecasters can and cannot tell you. They can tell you, with high confidence, that this whole stretch is dangerous. They cannot tell you which towns get hit, or on which afternoons, more than a day or two ahead of time. And that gap, the space between knowing a week is dangerous and being unable to warn a specific place, is the real story here. It is not a failure of technology. It is something built into the physics of the atmosphere itself. And over the next 20 minutes, we are going to walk through exactly what is coming day by day, and then explain precisely why this kind of weather defeats even the most advanced forecasting system on Earth. Let us start with the cause, because everything traces back to one feature, 5 to 7 miles above your head. The jet stream is a ribbon of fast-moving air high in the atmosphere, and it is the single most important control on weather across North America. It forms along the boundary where cold polar air meets warmer air to the south, and it winds around the hemisphere in a series of dips and bulges. The storms you experience at the surface do not really steer themselves. The jet stream steers them, so when you want to know what the weather is going to do, you look up at that ribbon and ask what shape it is in. Right now, the jet stream has a deep dip in it, and that dip is parked directly over the Rocky Mountains. Forecasters call a southward dip like that a trough. A trough creates rising motion in the atmosphere, and rising air cools, condenses, and builds thunderstorms. In simple terms, a trough is a storm factory. That part is normal. Troughs form all the time. What is not normal is that this trough is not moving. Troughs are supposed to progress from west to east, carrying their weather along with them, so the storm factory passes over you and then moves on. This one has stalled. It has dug in over the Rockies, and the forecast keeps it there for days. And a stalled trough does not behave like a passing storm. It behaves like a pump. Air curling around the base of that dip reaches out and pulls moisture in from two directions at once. Pacific moisture from the west, and Gulf of Mexico moisture from the south. Both streams are being funneled into the same part of the country, and as long as the trough sits there, the pump keeps running. Day after day, the atmosphere over the central and eastern United States gets reloaded with moisture and instability. Atmospheric scientists have studied this kind of stuck pattern directly. When the waves in the jet stream grow large enough, they can slow down and lock almost in place. Research published in the journal Nature Climate Change in 2020 has connected these stalled, high-amplitude patterns to long-lasting surface extremes, the heat waves and floods that linger, because the pattern producing them will not move. What is happening over the Rockies right now is a textbook case. The trough is stuck, so the threat is stuck. The threat already showed its hand yesterday. The active stretch opened yesterday across the southern plains, the central plains, and the Tennessee Valley, and the way yesterday unfolded is the template for the entire week ahead. In West Texas and western Oklahoma, the Storm Prediction Center, the federal agency in Norman, Oklahoma, that forecasts severe weather for the country, posted a slight risk. Do not let the word slight fool you. The agency uses a 5-level scale, running marginal, slight, enhanced, moderate, and high. Slight is the second rung, not the bottom. It means organized, severe thunderstorms are genuinely expected, and some will be strong enough to do real damage. The setup in Texas and Oklahoma was a weak disturbance sliding across Colorado, with a dry line at the surface, the boundary between humid Gulf air and bone-dry desert air, acting as the trigger for afternoon storms. Mid-level winds of 20 to 30 knots were enough to give those storms some structure, enough for a mix of clustered storms and the more dangerous rotating supercells. The hazards were damaging winds and large to very large hail. Near Amarillo and toward Wichita Falls, the forecast specifically called for hail up to the size of a baseball. That is a 3-inch ball of ice falling at highway speed, and it is not a nuisance. It shatters windshields, it dents a car roof deeply enough to total the vehicle, and it can seriously injure anyone caught outside. The simple advice on a day like that is to get your vehicle under cover before the afternoon storms develop. Farther north, in the Central Plains, a weak low-pressure system over South Dakota kicked off storms capable of quarter to half-dollar-sized hail near Omaha, the kind of ordinary isolated hailstorm the Central Plains sees routinely in May. Not a crisis, but worth knowing about. But the part of yesterday that genuinely concerned forecasters was farther east, in the Tennessee Valley, and the stretch of the Deep South known as Dixie Alley, where the Storm Prediction Center drew a tornado risk over roughly 10 million people. That threat deserves its own breakdown because it is a subtle one, and subtle threats are the ones that hurt people. The tornado risk yesterday stretched from the Mobile, Alabama area northeast through Lexington and Louisville, Kentucky, and it covered around 10 million people. Now, here's the subtle part. If you only looked at the instability, you might not have been impressed. The measure forecasters use is called CAPE, the stored explosive energy in the atmosphere, and yesterday across the Mid-South, the CAPE was relatively weak. The air was not loaded with the kind of raw power you see on a classic big tornado day in the plains, but instability is only half of the tornado recipe. The other half is wind shear, the change in wind speed and direction as you climb through the atmosphere. Shear is what makes a storm rotate. You can have modest instability, and if the shear is strong enough, the storms will still spin. And yesterday, across the Tennessee Valley, the shear was favorable. There was a broad zone of moderately strong southerly winds at low levels. The air was extremely humid with dew points up in the 70s, and there was enough low-level shear for forecasters to be genuinely worried about tornadoes. Mesocyclones, the rotating updrafts inside supercells, had already been observed in the region. The Storm Prediction Center placed its official confidence in the marginal category, the lowest rung, but the agency's own discussion explicitly stated that a tactical upgrade to part of the area remained possible. In plain language, that means the forecasters were watching closely and prepared to raise the threat level if the atmosphere kept trending the way it was trending. The peak window for the tornado threat ran roughly from 2 in the afternoon to 7 in the evening, with the focus near Huntsville and Florence, Alabama, and into northwestern Mississippi near Tupelo. And here is the question. Yesterday hands us the question that drives this entire story. Forecasters could see the rotation, they could see the shear, the moisture, the setup. They could draw a circle around 10 million people and say a tornado is possible inside this circle. So why could they not tell those 10 million people which towns? Why is the honest answer always somewhere in this region this afternoon instead of this street at this hour? Hold that question, because the answer is coming, and it is the most important part of this video. But first, there is one more piece of evidence to look at, and it is hiding inside the forecast itself. The Storm Prediction Center does not just forecast today, it issues outlooks days in advance, and watching how one of those outlooks changed over the past few days tells you everything about this pattern. Earlier this week, the outlook for the first Saturday of this stretch, when Saturday was still several days away, was essentially blank. It highlighted no severe weather areas at all. As far as the forecast could see at that range, Saturday looked quiet. Then, as Saturday moved closer, that same outlook filled in with 3 separate severe weather areas. Nothing about Saturday changed. The atmosphere did not suddenly decide to become dangerous. What changed is that Saturday moved closer, and as it moved closer, the forecast could finally resolve details that were always going to be there but were, at greater distance, simply invisible. The danger was always coming. The forecast just could not see it yet. Think about how that reframes a weather forecast. We tend to assume that when a forecast updates, it is because the forecasters got something wrong and are correcting it. That is not what happened here. The blank Saturday was not a mistake. It was an honest statement of what could be known at that range, which was not much. The 3-area Saturday was not a correction. It was an honest statement of what could be known once the day was near. Both versions were correct. They were correct about different amounts of distance. This is why, with a pattern like this one, you will hear forecasters openly commit to issuing updates every single day. It is not disorganization. It is the only honest way to forecast a pattern that yields its details a little at a time. And that raises the obvious question. Why does this pattern, specifically, refuse to be seen in advance? The answer has a name, and forecasters have a precise scientific reason for it. The atmosphere does things at different sizes, and that simple fact has enormous consequences. Meteorologists divide weather into scale categories. There is the large scale, the synoptic scale, which is the realm of the big features, the jet stream itself, the great troughs and ridges, a continent-spanning front. Synoptic features are thousands of miles across and last for days. And there is the small scale, the mesoscale, the realm of the individual thunderstorm, the cluster, the line, a feature a few miles to a few hundred miles across that lives for minutes to hours. Here is the rule that explains this entire week. Predictability is not the same at every scale. The bigger the feature, the further ahead you can forecast it. The synoptic scale pattern, the big jet stream setup, is predictable in a practical sense, out to a week or more. But the mesoscale, the individual rotating storm that actually drops a tornado, has a predictability measured not in days, but in hours. So think back to what we said about this pattern. It has no organized synoptic system. There is no big low, no sharp front steering the show. And at first that sounds like it should make the week calmer. But flip it around. If there were a big synoptic system in charge, the severe weather would inherit that system's predictability. The tornado threat would be tied to a front that forecasters could track for days. The bigness of the system would lend its predictability to the storms inside it. This pattern has handed the steering wheel to the mesoscale. With no big system to organize them, the storms this week are triggered and located by small-scale features, an outflow boundary left behind by yesterday's storms, a subtle line where two air currents meet, a local patch of clearing sky that lets the sun heat the ground a few degrees hotter. Those features decide where the dangerous storm goes, and those features have a predictability of hours. The pattern, by removing the big organizing system, stripped away the very thing that would have made the threat forecastable in advance. The pattern is predictable. The storms inside it are not. And the reason that is true, it all traces back to a single accident in 1961. In 1961, a meteorologist named Edward Lorenz was running an early weather simulation on a primitive computer at the Massachusetts Institute of Technology. He wanted to re-examine part of a run, so he took a shortcut. He typed in a set of numbers from the middle of an earlier printout and set the machine going again from there. It should have reproduced the original run exactly. It did not. The new run tracked the original closely at first, then drifted, then diverged completely until the two simulated weathers had nothing in common. Lorenz hunted for the error and found something that was not an error at all. The computer stored its numbers to 6 decimal places, but the printout he typed from only showed 3. He had restarted the run with numbers that were off by about 1 part in 1,000, a difference so small everyone at the time would have called it meaningless. And that difference had grown until it swallowed the entire forecast. This is the discovery that became the foundation of chaos theory. Its formal name is sensitive dependence on initial conditions, and its famous nickname is the butterfly effect. It is not a vague statement that small things matter. It is the precise finding that in a system like the atmosphere, a tiny difference in the starting state does not stay tiny. It compounds, it doubles and doubles again, until it is as large as the thing you were trying to predict. And at that point, the prediction is gone. The consequence is permanent, and it is huge. Because the atmosphere is chaotic, there is a hard ceiling on how far ahead the weather can be predicted by anyone, with any technology, ever. For the big synoptic scale pattern, that ceiling sits at roughly 2 weeks. And here is where it connects to this week. Lorenz's error growth does not run at one speed. It runs faster when the physics is more violent, and there is almost nothing more violent than a growing thunderstorm. The error growth that takes 2 weeks on the large scale can run its entire course in a single afternoon inside a field of storms. That is why no one could tell those 10 million people which town. The dangerous storm depends on details too small to ever fully measure, and the physics of a thunderstorm amplifies those details into the difference between a quiet sky and a tornado, all within hours. If chaos puts a wall around the future, you might wonder how forecasters do anything useful at all. The answer is one of the genuine triumphs of modern science, and it explains why the forecast for this dangerous week, while uncertain, is also deeply honest. For most of the 20th century, forecasting tried to make a single best prediction. You measure the atmosphere, you run the model once, and the answer it gives you is the forecast. But in a chaotic system, that approach has a fatal flaw. Your measurement of the atmosphere is never perfect, so your one starting point is never exactly right, and your one forecast is just one of many you could have gotten from the many slightly different starting points that were all equally consistent with your data. So forecasters made a profound shift. Instead of running the model once, they run it many times, each from a slightly different but equally plausible version of the current atmosphere. This is called ensemble forecasting, and the clever part is what you do with it. If all the runs produce nearly the same forecast, confidence is high, the outcome is robust, and you can forecast it days ahead. But if the runs scatter, some showing a quiet day and some a severe outbreak, that scatter is also information. It is telling you precisely that this situation cannot be pinned down and that no honest forecaster should pretend otherwise. So look again at the Storm Prediction Center's outlook for this week. When the agency draws a broad marginal risk over a wide, vague area instead of a sharp, tightly drawn higher risk, that is not timidity. That is the ensemble reporting that the threat genuinely cannot be localized yet, and the forecasters being honest enough to draw what the ensemble actually shows. And that Saturday outlook filling in from 0 areas to 3 was the ensemble converging as Saturday moved inside the predictability horizon. The forecast for the next 10 days is not a confident story, and a confident story would be a lie. What you are getting instead is a truthful map of uncertainty. There is one more thing this stuck pattern is doing, and it is the opposite of a threat. For months, parts of the Deep South and the Southeast have been locked in a serious drought, the ground cracked and dry, fire danger climbing, and the very same stalled trough that is loading half the country with severe weather is, at the same time, the best thing that has happened to those drought-stricken regions in a long time. Over the coming week, the Deep South and Southeast are forecast to receive a widespread 2 to 5 inches of rain. For that parched ground, that is not a disaster, that is a rescue. This is the strange, double-edged nature of a jet stream pattern. It is not good or evil, it is a configuration, and this single configuration is delivering a destructive, severe weather threat and a drought-breaking rain to overlapping parts of the same country at the same time. The honest framing is that this is broadly beneficial rain that carries a localized flooding risk on the days the downpours are heaviest. We are already seeing the sharp end of that, with a flash flood warning around Mobile, Alabama, citing 6 to 9 inches of rain already fallen. Nationally, the alert picture includes 37 flood warnings, 19 flood watches, and 7 flash flood warnings. The same pattern has yet another face, aimed at the East Coast over the holiday weekend. For the eastern third of the country, the stuck trough is delivering a long, cool, gray soaking. The Philadelphia National Weather Service office described it as having the feel of a March nor'easter in late May, with coastal wind gusts toward 40 miles per hour and daytime highs stuck in the 40s and 50s. The New York City office is forecasting a prolonged soaking rain, with around 1 3/4 to 2 3/4 inches over a 60-hour window, and it notes the atmospheric moisture is running in the 90th percentile. Boston measured moisture 1.5 to 2 standard deviations above the late May average. Those statistics mean this is not an ordinary rainy weekend. It is a genuinely anomalous one. And out in the desert Southwest, the same pattern delivers nothing at all. The geometry of the trough funnels the moisture into the central and eastern states and leaves the Southwest dry on the wrong side of the whole configuration, with the ongoing wildfire concern there getting no relief. One jet stream pattern, 4 different weathers all at once, all from the same stuck trough. The pattern is not finished evolving, and as we look toward the middle and end of next week, the forecast arrives at a genuine fork in the road. Through the weekend, the stuck trough holds, and the daily severe weather threat continues across the central and southern plains and the southeast. Early next week, a ridge, a northward bulge of the jet stream that suppresses organized storms, builds across the Great Plains. But that ridge does not shut the threat off. Underneath it, the atmosphere stays loaded with instability, so scattered, hard-to-place severe storms keep firing day after day. Then comes the fork. Around the middle of next week, forecast models show growing agreement on a large low-pressure system developing along the west coast. That system is the whole question, and it is genuinely a coin still in the air. If that west coast low ejects eastward, driving up and over the Rocky Mountains and out into the plains, it becomes the organizing system this pattern has lacked from the start. It would arrive over an atmosphere primed with days of stored fuel and trigger a much more widespread, much more intense, and crucially, much more predictable, severe weather outbreak across the Great Plains and the Midwest. Predictable because, at last, there would be a big system to track. If, instead, that low stalls and meanders over the Great Basin, over Nevada and Utah, without ever driving out into the plains, then the end of next week looks like the rest of this stretch. More scattered, unpredictable, mesoscale severe weather, more instability with no organizing trigger. And right now, no one can tell you which of those two outcomes happens, because that system is roughly a week away, right at the ragged edge of the predictability horizon. Notice the irony in that. The single most dangerous thing that could happen, a widespread organized outbreak, is also the single most predictable thing, while the less dangerous road, more scattered storms, is the less predictable one. The pattern has arranged things so that more danger would come with more warning. So what do you actually do with all of this over the next 10 days? You do the simple, concrete things, and you do them precisely because the threat is unpredictable. Keep the emergency alerts on your phone switched on, with the volume up, especially overnight. In a pattern driven by small-scale storms, a warning may come with a lead time of minutes, not hours. And a phone that wakes you is worth more than any long-range forecast. Know in advance where your safe place is. An interior room on the lowest floor, away from windows, so that if a warning comes, you're not deciding under pressure. And check the forecast every single day. Not because the forecasters got it wrong yesterday, but because each new day has finally moved close enough to be seen clearly. It is also worth keeping the two kinds of forecasting straight because they do different jobs. The multi-day outlook tells you that a stretch of days is dangerous, but it cannot give you the address. The short fuse warning, the tornado warning that lands on your phone, is a different tool entirely. It is issued minutes ahead, often from radar watching a specific storm rotate in real time, and that warning system is extraordinarily good. The predictability barrier limits the long-range outlook. It does not cripple the short fuse warning. So use the daily outlook to stay ready and treat the warning, when it comes, as the real act now signal that it is. The bottom line is this: the next 10 days are dangerous. They are dangerous every day, and the danger is real from the Rockies to the East Coast. Forecasters will not be able to tell you in advance exactly where it lands, and that is not a failure on their part. It is the honest limit of what a chaotic atmosphere allows anyone to know. The jet stream is not broken. It is simply locked into a configuration that is going to spend the next week and a half showing the United States in real time the exact boundary of what can be predicted about tomorrow. Stay alert, keep your plan ready, and check back every day, because in a pattern like this one, the forecast that matters is the one that gets updated.